Okay, so first off, all this content, everything I'll be writing, can be found within the content library underneath Algebra 2. So first off today, we're going to look at our introduction. So our learning intentions for this topic are going to include the concept of equality, what is meant by a linear equation. Then we're going to learn how to solve linear equations in one variable, with one operation, with more than one operation, with one variable on either side of the equal sign, when they contain brackets, and we're also going to look at how we can use linear equations to solve word problems. What we're looking at specifically today are the concept of equality, what is meant by a linear equation, and then we're going to look at how to solve linear equations where we only need to do one operation. So again, our operations are adding, subtracting, multiplying, and dividing. So first off, what is an equation? Well, written just here down below, we have an example of a very simple one. So any mathematical statement that has an equal sign in it is an equation. So we know that if we have 3, we add 2 to it, it is going to be equal to 5. This is an example of a very simple equation, and we're going to learn how to deal with ones that are more complicated in this chapter. So solving an equation involves finding out the value of an unknown variable. So usually we'll have ones that involve algebra. Now, linear equations, we'll see them referenced throughout the chapter. And a linear equation, to give an example of one. So something that could be represented by a linear equation could include a daisy flower that is 15 millimeters tall, and if it grows 5 millimeters per day. So we can see here I've done out an X and a Y axis for this, and I just forgot to put the little dots along here as well. So on day 1, we know that it is 15 millimeters tall, because we've said the daisy is 15 millimeters tall. So we can go up to day 1, and we say it was 15 millimeters tall. On day 2, it's going to be 5 millimeters taller again. Day 3, it's going to be 5 millimeters taller. So day 1, 15, day 2, 20, day 3 was 25, day 4 will be 30, and day 5 will be 35. So if we look at all those dots lined up there, we can see that if we connect them together, we have a line. So that's where the word linear equations come from. So linear equations can be represented by lines. So linear, if we look at that word, be broken down to make a line. Okay, so that's where the word linear equation comes from. So we're going to look at equations that represent lines. So we're going to use a little online demonstration here. So we're going to look at a one-step linear equation. So I want to set up or model this equation. So this is an example of an equation we could be given to solve. So if we want to set this up, well, I have the options of putting x's, negative ones, and positive ones on either side. So if we look on the left-hand side of this equation where the x plus 3 is, we have an x, and we have 1, 2, 3. So that's x plus 3 we have now on the left-hand side. Now, if we look at this balance, this is like an old-fashioned balance that your grannies and granddads may have used, your great-grannies and great-granddads might have used, where you'd put weights on one side, and you would then have to balance the amount of product you'd want to use on the other side. So you might put the 50-gram weight on one side, and then you'd put 50 grams of flour on the other side, and you keep putting flour on until you had 50 grams. So right now, if we look at our scales, the left-hand side is tipped down, and the right-hand side is tipped up. So that means our left-hand side is heavier than our right-hand side. And if we look at what this equation was set up, it said x plus 3 was equal to 2. So it's equal to, well, we have to look at our other side here. So our other side has 0 at the minute. We'll add 1, we'll add 2. So now we have an x on the left-hand side with 1, 2, 3 positive numbers. That's x plus 3. And on the right-hand side of our equation, we have a positive 1 and another positive 1. So that is 2. So we've represented the equation x plus 3 is equal to 2 on this balance. You can kind of imagine like the middle of the balance is like where the equals is. So now I need to isolate the x tiles. So this is where I have to use my first step. I have x plus 3 on the left-hand side, and I have plus 2 on the other. I want to take away one of these positive ones from the left-hand side. So when I take away a positive 1, I press -1. Now I'm left with x plus 2 is equal to 1. And you'll notice that when I press that -1 button, it actually takes 1 away from both sides of the equation. That's one of the first rules we have with equations, where we have to do what we do to one side to both sides of the equation. So now I have x plus 1 is equal to 0. Well, I'm going to take away another 1 from my left-hand side, so I use the -1. And now I'm left with x is equal to -1. So if x is equal to -1, I just have to enter here -1. And check my answer. That's me done. So we'll do another example here. We want to set up model this equation. So we have x plus 4 is equal to 3. Well, I need an x on that side, and I'll need another 4. And on the right-hand side, I'll need 13. Okay, so that's me model the equation. That bit's handy. So I can just hit my tick there now. Next, I need to isolate the x tiles. So isolating the x tiles, just say that again. That means I want to have x only on the left-hand side and numbers only on the right-hand side. So right now I have an x plus 4 on the left and a 13 on the right. So I'm going to take 1 away from the left-hand side. And when I did that, it took 1 away from the right-hand side as well. I'll take 1 away from the left-hand side, it takes 1 away from the right as well. And every time I take 1 away here, the equation stays balanced. It stays equal. And then I'm left with x is equal to 9. So I have to enter in x is equal to 9. And that's my equation done and sorted. So that's our introduction complete. And now we want to go into looking at how do we add and subtract in equations. So here's some examples of equations similar to the one we've seen previously on the interactive website. And here are 3 examples that I'm going to do out below here. So the first one tells us that x plus 5 is equal to 9. Now we've all seen questions along the lines of a blank box plus a number is equal to another number. And I'm sure most of you right now are thinking, right, well, I could run through different numbers. I could try 1 plus 5 is equal to 9. Well, 1 plus 5 would only make me 6. 2 plus 5 would give me 7, so I'm getting closer. 3 plus 5 will get me to 8, and 4 plus 5 will get me to 9. But we do need to learn about how to implement our rules, okay? So we have an x plus 5 is equal to 9. Well, if I want to only have x's on the left-hand side of this equation, and I only want to have numbers on the right-hand side of this equation, I need to think about what I have so far. So right now I have an x plus a 5 is equal to 9. And I don't want to have that 5 there. So because I don't want to have that 5 there, I can take 5 away from the left-hand side of the equation. But if I do that, I will also have to do that to the other side of the equation. So then I will have x plus 5 minus 5 is equal to 9 minus 5. Then that will give me the next line of my equation. One sec. So I have an x plus 5, take away a 5. They'll both cancel out, because if I have 5, I take 5 away, I'm left with nothing. So then I'll have x is equal to 9 minus 5 is 4. Now, don't let me forget to put in my which implies signs, or my lecturer from college years ago would beat me up. Now, the next one we can look at. I have an x take away 3 is equal to 9. So we again can be thinking some number take away 3 would leave us with 9. So we can think, okay, I have an x take away 3 is equal to 9. Well, I don't want to have a negative 3 on this side of the equation. So if I don't want to have a negative 3, I could add 3 to that side of the equation. If I add 3 to that side of the equation, I'll have to add 3 to the other side of the equation as well. Then I'll be left with x minus 3 plus 3 is equal to 9 plus 3 is 12. Minus 3 plus 3, they'll cancel each other out. I'll be left with 0. And then I'll be left with x is equal to 12. Now for our third example, we have minus x minus 2 is equal to negative 6. So we can start again. Nothing changes massively just because they're negative numbers. We want to have the x on the left-hand side and all the numbers on the right. Well, I have a negative 2 here, so if I add 2 to this side and add 2 to this side, those negative and positive 2 will cancel each other out here. And I'll be left with x alone on that left-hand side of the equation. So I have negative x is equal to minus 6 plus 2 is equal to minus 4. Because I have a negative 6 and I'm adding 2 to it, so it's going to become less negative, so it becomes negative 4. Now, if I know that negative 6 is equal to negative 4, I could probably make a guess about what positive x would be equal to. So positive x would be equal to positive 4. And how I can do that is by technically multiplying both sides by negative 1. So both sides of the equation are multiplied by negative 1. But it's very simple for us to think as well. If negative 4 is equal to negative x, then positive x will be equal to positive 4 as well. Now, you guys can go to page 244 in your book. So that's page 244. And on page 244, you can have a go questions 1 to 20. Do them in your copies, and then you can take a photo of that and upload it into the OneNote as described already. So next up, we have to look at multiplying and dividing in equations. So we've been told to solve the following equations that are a bit different to any one that we've seen before already. Now, we'll look at the examples here first of all. So let's say I have 2x is equal to 8. So I like to always think of them in terms of if I'm buying something. So imagine I know that 2 somethings, so we'll say 2 bars, cost €8. Most of us probably would say, well, if 2 bars cost €8, if I only want to buy one of them, that's half the amount, so it'll be half the price. So 1 bar will be equal to €4. But we need to be able to work this for harder examples as well. So we have to look at what our rule will be. So we have 2x is equal to 8. Then we can say that we want to find out what only one x is. If we want to find out what only one x is, look at what number is in front of the x. So we have 2 in front of x. 2 is the coefficient of x. So that means we can say that if we take that coefficient of x and divide both sides by it, we'll be able to find out what x is by itself. So 2x's divided by 2 will be left with only 1x. 8 divided by 2 will be left with 4. Because imagine that's 8 things divided into 2 piles, we're left with 4. So we then have solved the equation because we've isolated it to x is equal to 4. Now imagine we take this other example where we have x divided by 10 is equal to 3. Well, no need for me to write that out again, but x divided by 10 is equal to 3. So imagine it as something divided by 10 costs €3. So if you're to buy a fraction of something, so imagine a shop was selling Again, we could stick with a chocolate bar example. Imagine it was a very expensive chocolate bar. But imagine it had the chocolate bar divided out into 10 sections. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now imagine it's not very great drawing, but imagine we have 10 pieces there and you're only going to buy one of them. And you're saying that that one piece out of 10 is going to cost 3. How could you figure out what the entire thing will cost? Well, you might say, well, if one of them costs 3, but we want to buy 10 of them, we're going to have to spend 10 times the amount. So we could then say that the whole thing would be 3 multiplied by 10, which would be 30. But again, we want to learn our rules for equations. So we have x divided by 10 is equal to 3. So if we have x divided by 10 is equal to 3, we can see that the variable x is divided by 10. So if we take that 10 and we multiply both sides by 10, something interesting will happen. So if I have x divided by 10 and it's multiplied by 10, well, what I'll end up with is 10 multiplied by x, over 1 multiplied by 10 is equal to 30. So then I have 10 x's divided by 10 is equal to 30. Well, 10 x's divided by 10, and we'll be left with only x. So x is equal to 30. So to figure that out, we check what is the x divided by, multiply both sides by what it's divided by, and we'll end up with x is equal to 30. And again, I don't want to forget these.